Mechanical Engineering and IIEDC National Institute of Technology, Srinagar. Today's first session will be delivered by Dr. Dinesh Kumar R, the program coordinator of this workshop and an assistant professor, Department of Mechanical Engineering, NIT Srinagar. His doctorate research was an ISRO-sponsored project in friction stir welding of cryogenic fuel tank. His areas of research include underwater welding, FSW, and additive manufacturing. He has 10 publications in SCI and Scopus Index journals, and he has also contributed three book chapters in metal additive manufacturing. He has presented various papers at international conferences. He was the founder president of the Research Scholars Forum at NIT Trichy, leading more than 1,500 research scholars and organized around 20 events, including workshops, guest lectures. He was a member of the NBA accreditation team, which was successful in getting the Washington Accord accreditation in production and metallurgy departments of NIT Trichy. With this brief intro, I request Dr. Dinesh to begin his lecture. Over to you, sir. Sir, you aren't audible.
Thank you. Sorry, good morning, guys. As today's topic is completely on research possibilities in using CNCs, and as I said, my area will be majorly focusing on welding and additive manufacturing. Of course, I'll just introduce. Is there any entrepreneur or someone who just want to take your business? CNC is the best model which can pull you a lot of money in the market because there is a lot of scope. We don't have a skilled labor in the market. So in that particular condition, what we can actually do with this is this CNC coding or CNC skill, whatever you acquire from this, can drive you a huge market. So I'll also touch something on entrepreneurship, possibilities, whatever is there. So I'll try to combine both. What are the research possibilities? What are the entrepreneurship possibilities? And I'll try to introduce to your software where we started with a basic simulation. So that basic simulation is mandatory for everything because now even the things are more coordinate machines are into picture, more the design to coding conversion as in process, but still there are always eccentric thing that if you don't understand the basics you won't know what is happening with the conversion of your diagram to coding or something. So in that case, what I'll do is I'll just give you brief intro about how the coding actually works. I'll just simulate something on how the coding process actually works. So this is the outline of the schedule for the day. So let me start with the process. Is my screen visible?
Yes, sir.
Okay. If possible, please interact because I cannot see your face behind the screen. Yeah. Is it moving actually? Is it moving to next screen? You could see the next screen or?
Yes, sir, we can see it.
Okay, cool. So let me start with what do you think about what is CNC? What is CNC? What is actually this expansion for this word CNCs? What are yours?
Computer numerical control.
Control numeric.
Computer numerical control. This all what all we know about CNCs, but my approach towards CNC is completely different. This completely deals with coordinate system. So my view towards CNC is coordinates controlled by numerics. The coordinates that are controlled by numerics. So CNC is completely applicable where where you have the control of coordinates in every system. Either it is going to be in x-axis or y-axis or z-axis. Either it is going to be in x or y or z. So the coordinate that is going to be controlled by any of the numerical system, either it is going to be 0 0 or 10 comma 0 0 0 0. So it will be around 10 comma 0 comma 10 comma 0 or 0 comma 0 comma 10. So all this coordinates that is completely controlled by means of numerical. Maybe it can be of any dimension, maybe of inches or millimeter or nanometer or decimeter, like, or even kilometer. So whatever is being controlled by the coordinate system of the world or the earth, like, or the component or the equipment or the whatever we see over there is the backend, mean front end data, but backend data is completely controlled by computer numerical control or the numerical coordinates control. Like the coordinates is controlling all the system, whatever the process it is going to be. So that is what will be the eye opener in this session. So if you think like CNC is only for machining, just throw that concept from your mind, because CNC has a lot of possibility. Only thing is you should know what is actually going to give you an input in this particular sequences, like what are the coordinates that is going to open up the research possibilities in this particular area, of course the entrepreneurship activity in this particular area, right? So it is completely going to discuss on coordinate system, nothing more. Like it will be completely based on coordinate system. Now you could imagine like what are the things that is completely controlled by coordinates. If you think about your responsibility, everything will be controlled by some coordinate system or by some control system by means of application of numerical. So I'm going to incorporate all those things, the backend data which is being used for running your system completely. So the basic understanding of CNC, what will be the output if you know what is the basis of CNC, where all it can be applicable. So of course, like this plays a vital role for designing and graphics. So without coordinates, you will not know what is design and what is graphics. So only if you understand what is coordinate system, then you can go for design. Only if you go for design, then you can create a product. Only if you create a product, then you go for machining. And again, for machining or cutting or welding, whatever the process you are going to know, you should know what is the profile it is going to be. And it is a reverse data where when the profile is going to be generated, it will be like you will be knowing what is the design. From the design, you will know what is the coordinate system. For the coordinate system, you should have a number control. So each and everything what is being applicable in the day-to-day process, like what are the product you see, what even when you walk, it is going to be completely on a coordinate system. You walk in x-axis and you take a left and y-axis, and if you jump you go in y-axis. So all this movement is completely controlled by this, but we are not understanding the basic thing. We have a normal perception like completely CNC is based on some machining or some other operation, maybe some cutting or some welding operation, but it has a wide opening. Just to open up that, we started this workshop. So starting with this, I'll start with the basic machining, like whatever we have. The afternoon session, those who are attending, you might be knowing like some of the few coding processes, how to utilize the machine, how to check with the process, that would be given. But what are the machines we have? This is all about the machining center, like except surface surface finishing or surface toughness, like surface finishing you can do n number of processes. Either it is going to be cutting, either it is going to be drilling, or it is going to be probing, or it is going to be milling. Whatever the process, it can be done completely with this particular thing. And apart from that, apart from this particular machine, what will be the output from that particular session is what are the other research possibility using CNC, like computer numerical. If you are knowing a basic programming in CNC, where you can apply for it, what are the themes you can apply for it, that we'll be discussing in this. So of course, like you have plenty of opportunity in machining. Of course, when you come to forming, we again, and when you come to welding, of course you have. When you come to additive manufacturing, of course you have lot, because everything is controlled by the coordinate system. And other possibilities, what are the other possibilities where you can't even imagine, like what are the other possibilities which is completely controlled by your computer implementer. If you know what is the coordinate system and what is the coding which is being used, you can control the entire thing with this CNC basic machining operation. That's what we'll be some noise is coming in the background, right? So machining or cutting, First, of course, we start with turning. So when we take with basic turning operation, you have a shaft or you have something which is can be done. So that can go for a phasing operation, that can go for turning operation. And what is the resist possibility in this? Now micro machining has evolved into a serious process, micro machining of intricate shapes. So whatever you do, as Noor sir was handling some session in last yesterday's session, he was speaking about the micro machining completely of removal of small chips. It is like removal of layer by layer in the micro level. So that has a wide scope right now in the field of turning when you go for micro machining. So when you go for a surgical equipments, it is mostly used in surgical equipments. So when you go for surgical equipment manufacturing, this micro machining plays a vital role, or micro turning plays a vital role in getting your product output done, and that area plays a huge market because each and every surgical instrument like or equipment whatever you are having, which has the sophisticated structure or accurate level of maybe in micron level of accuracy, the cost of making that goes in maybe 10,000 or even in lakhs. So for those components like this turning operation, the what are the basic thing what you are going to learn in this CNC is going to have a vital impact in it. And what will be the like commercial output, what you can think about a product from this turning operation. When you have a when you are quite good in turning, what are the products you can manufacture from this? What are the entrepreneurial activity you can manufacture from this? Any idea about it? What are the product output from this that can be sold in the market directly? Like mostly most of the guys like those who are attending uses this dumbbell. So if you check out each and everything in this is done by turning process, this is done by turning process, this is done by turning process, then it comes with assembly. So basically when you take the what is the entrepreneurial activity from this particular thing, apart considering research, what are the things you can manufacture? If you know just a turning process, you can very well make something like this. Or you have intricate shapes where the structures is being made where it is completely allied when maybe like what are the things you have in wooden carvings, something like that, that everything can be done with this process. So mostly like when you go for turning process, micro machining plays a vital role. Then comes to milling process. When you are coming to basic milling process in CNC, what is the most intricate structure what will be tried by every expert in this machining center is making of a bevel here. So they will have a structure like this. Making of this intricate shapes gives you a complete clarity on milling operation, and once you know exact milling operation, there are a lot of possibility in research where you always go for surface finishing of any machine components, or you always go for manufacturing any engine designs, like whatever the engine design we have in aerospace, everything is right now completely it is being milled and getting fabricated. You don't go for any welding or you don't go for any additive manufacturing. It is not even installed yet now, they are still in research. So when you want to try out something on aerospace design, your milling knowledge, like the coding design based on your milling knowledge, is going to help you like anything in that particular processes. So apart from that, what is the entrepreneurship thing you can try out with this is wood carving. So what are the wood carving which is happening? Everything is based on the milling operation, where you can see something on doors. Earlier it was like carving was completely done with hand. Now it is completely based on CNC milling operation, where what are the landscape generation is the beautiful task which is done with your milling operation. Suppose like you have some landscape like where you have intrinsic mountain or something. So these things can be completely done with this milling operation in a micro level way. When you go for a first layers of removal of material, then you go for the micro tips, with that you create the intricate shapes of the landscape whichever being available. And this is being right now in the hot topic of commercialization in Valley, because when we met like this director MSME last week, he gave us a project on how to make the landscape of valley and that can be sold out to the entire country or the globe. So in that case, like this milling operation, when you have adequate knowledge in this, that is going to have a better business opportunity in your landscape manufacturing or the wood carving industry. And what is going to be the research output of this? If you know the milling, you know something on aerospace, and what all can be things which can be the most vital thing in the milling operation is you can go for die designing. What are the die designing you go like in this particular area? This again has a vital scope where when you have a hardened material that has to be designed, that basic profile is completely manufactured by milling process. When you learn this milling process, again you have wider scope in getting into different possible area of research. That is what all you can get from milling, and this is whatever I'm saying is completely limited. Like I'm not exaggerating or I'm not going in deep. Like these are the small operations that can be done with your research possibility, as well as like when you learn something about this, you have a huge potential in market to commercialize it into a product, right? Of course, this is just to show like what the programming normally do with your CNC milling. What are the outputs you can play? Again, you have like laser engraving in it, laser machining in it. Like engraving is again a technique where you create some structure maybe in glass vessels or something. You create some structures over it using laser pointers, everything. So machining, again, this CNC control actually tries to control the laser point as well, where that is also being used. Other than that, you have like something on drilling and hobbing, where hobbing is the most vital thing, because now plastic gears are actually replaced with the metal gears to reduce the weight for sophisticated structures. So the here hobbing like is going to have a major impact. So gear manufacturing, that too in plastic field, has a wide research scopes. If you know something on basic simulation, mean basic programming on CNC, how to go for a hair carving module, right? Now we'll move on with directly from machining to cutting. Of course, like here it comes with different modules in laser cutting as well, where you have the intricate profiles. What are the profiles you are getting engraved or carved, that is completely done with laser cutting? And what is the research possibility with this laser cutting? Now the sophisticated micro manufacturing, it is completely is in need of product that has to be maintained at the accuracy level of maybe around 5 to 10 microns. And getting this product over machining, it is going to cost you in thousands or lakhs. But when you go for laser cutting, the same operation that can be easily done with few thousands. So that is what the major advantage when you go with laser cutting. And when you go for the entrepreneurship activity or entrepreneurship opening with this laser cutting, you have a very good design. This is completely made of laser cutting. So they spark the laser at each and every point of the system, and they take the coordinates of the system. This is completely 2D, and even 3D is completely possible with this. When you learn this CNC programming, what that can give you as an output is this laser cutting or designing, which has a huge scope in market when you go for aesthetics. Now you could imagine what are the engraving item, what are the embedded item you find in the market, or what are the shield or prices you receive that is getting engraved or embossed in a shield. So everything is based on laser cutting. So this technology is again huge demand in market. I know a guy who started this business with just around 12 to 13 lakhs of investment, and he was a ME graduate from, of course, a reputed college. He got involved in this process, and he was doing some project with this process. So then he started ideating. With the process and started collecting data over there. He started constructing his own machine, and he started a startup for shield printing. So whatever the shape you give, either we give our college logo or your name has to be embedded, everything can be completely laser cutted, and you will be completely getting. If it is going to be in metal, you have to go for, of course, laser to get a better profile, or in glass you have to go for laser. When you want to go for wood, of course your milling operation will give you a better result out of it. So these are the few research opportunities what you can get with the laser cutting. When you go for defense products, this laser cutting has a vital scope where they need some maybe like when you go for defense, you have the bullets which are bullets or guns which are being manufactured. Everything is on of fingertip where you have a short pointer that when you go for this milling or milling operation, that is again going to take a huge cost for manufacturing. But when you replace that completely with your laser cutting operation, of course that is going to have a vital impact in defense industry as well. So those are the things what you can have mostly with your laser cutting operations. Then comes with water jet machining or cutting. Of course you would have read something about this in your non-traditional machining process, but what is the actual application in this? Yeah, when you have some brittle material, or some, when you have some ceramics, or when you have some other composite that has to be machined, in that condition you cannot go for the milling operation or laser cutting, which is not going to have you the proper output whatever you expect. In that particular condition, this water jet machining or cutting, which just uses the abrasive slurry based on the profile structure or based on the surface finish or based on the intricate structure, you can play with the slurries, the abrasive slurries, whatever it is going to bear. If it is going to be in micro level, of course you will get a better surface finish. If it is going to be in macro level or maybe in 100 microns rather than 5 microns or 10 microns, of course the profile is going to be quite higher. In that particular sense, you have lot of scope in this cutting operations. So then comes with your EDM. Again, when you think like wire EDM process or EDM process, which you profile intricate shapes like just by moving of this, again that trends with your CNC milling operations, I mean CNC simulators, where you create the profile, you get the profile of it, and then you start with a machine that will touch, spark it and move on, that will touch, spark it and move on, and the continuous spark over it, the electrical energy which is being converted into heat energy, that creates an intricate profile, and that is completely based on your basic CNC control, because the backend coding will be completely on CNC. Without CNC programming you can yeah. Right, thank you. So all this intricate structure, whatever is being manufactured, even in your EDM, everything will be going on with your CNC process, right? So everything is going to be controlled with your just your basic coordinate system, whatever you are learning, or some maybe around 10 to 20 G codes and M codes that you always put in your mind to understand those processes. So EDM again as a waterfall now almost like I say like this is completely developed, but still there are too many researchers those who are working on electrical discharge machining technology or wire cut EDM technology that creates intricate profile, like what are the things has to be done. The sharp thing, if it is going to be sheet or a plate, like where you cannot directly go for machining, in that particular condition when you want to manufacture something like that, you can go for directly wire EDM process. Of course, like that has to be understood with the knowledge of medium, because only then you will understand what is the design which is being applied and what is the coding which is being applied, right? So these intricate, I mean, structures are being manufactured by wire EDM process, where you cut with that and you take a precise thing which is not completely feasible with your milling or gear hobbing process, because these are all of microstructure where you cannot have any other structure with an intricate shape. In that condition, this EDM technology is going to have as a replacement for micro machining processes. So these are the research opportunity what you have in this, and what will be the entrepreneurship point of this. Of course, now people are more into customization, more into product development in this time. In that case, they want something which has to be completely embedded with this technology. So all those intricate steps, whatever you want to manufacture with that has wide scope, but I don't say this has a vital scope for entrepreneurship activity unless until it is going to be industry oriented. So this technology is completely based on industry oriented, not on people oriented for the products. So if you want to select this technology, you have to understand which industry is having this technology being applicable, and based on that you have to start with your research and what are the development scope you can bring over it, right? Then forming. Next session, my friend Amrut like from SVNAT, he has a wide experience on farming. I'll just give brief about it because I'm not a one who do farming on this. But still, if you think about farming, where this CNC can be applicable, any idea on it? Normal CNC, where it is being applicable? Farming operation. Norming farming operation. What do you know where it is being applicable? Right. The simple thing is you have a sheet, you roll into tube, and the tube should not be oval. So to maintain that intricate shape, you should know what are the coordinates completely controlled with the process. You can normally go for a rolling mill to get it out. The problem with that is when you go for small pipes which is to be material, either you have to go for extrusion process or the extrusion process to get the tube. Again, it is not going to be that easy to extrude the micro level tube. In that condition, what you have to do is you have to go for a intricate shape of thing, where the problem in this forming of small tubules, when it is going to be human implants, like whenever you have some things that has to be sent through your blood vessel or something, that components will be very minimal, very small in structure. That micro level has to be formed in micro level, and that has to be written. So the simple forming operation will be of your things, and you have a huge scope on this forming in surgeries or medical devices. So that has to have each and every intricate forming has to be done in that particular thing. This is mostly used in that particular sequences. Then it is going to be incremental sheet metal forming. So next session will be completely on this. He'll be explaining you a complete set of what is incremental sheet metal forming. What is the advantage of this incremental sheet metal forming? How this CNC is going to be used over there is, when you have a sheet, it forms that layer by layer. It pushes, a gradual pressure will be applied to get the intricate shape, so that you don't have any impact on the load which is going to create any crack, or you don't have any excessive forming in a particular area which is going to be weakened in that particular things. So what is the major advantage of this incremental sheet metal forming or simple forming? Or as you see over here, the intricate shapes are completely formed. So when you go for a normal forming, what will be the problem is this edges, whatever you have, due to the maximum force applied, what are the maximum strain created, stress applied over this, there will be a maximum strain created in it, which will make this joints to be very weak. In that condition, to get the complete module into be a perfect thing, you go for sheet metal, incremental sheet metal forming. And this incremental sheet metal forming has a wide scope of research, where still people are balancing to get it, because like the complexity increases with this thing. So there are a lot of research going on this particular sheet metal, incremental sheet metal forming, that you will see in next session. So this is some examples of this sheet metal forming, how this incremental sheet metal forming actually works. You have a normal space. With this sheet metal forming, you create your entire profile of your body. That's how this is being generated. So again, this has a wide scope with research everything. Then final thing in your forming will be completely on your superplastic forming. Have you ever heard about this superplastic forming? Superplastic forming are the one which gives you 100 times increase in area, 1 to 100 times. Maybe like this can give area stretch of incremental sheet metal can be around 10 to 20 or maybe around 40 times. But when you go for superplastic forming, that gives you an intricate shape which can be around 100 times. So the surface area, whatever you have, without any defect in or loss in strength, you can stretch it to 100 times. Maybe like 1 centimeter can be stretched into 100 centimeter without without having any loss in the strength. So that is mostly used in aerospace, because like they need light material with the strength which is being maintained. So in that particular strength, like this super plastic forming, this goes to the intricate state where the complete things will be stretched with the same level. The same thing with the uniform thickness will be stretched into a complete shape where the strength will be maintained throughout the process. That gives a wide scope, and this is still in research. You cannot find too many research in superplastic forming because we don't have that much facility in most of the things, but still few NITs and IITs are having superplastic forming technology where this portion is completely on your research topic. Like you have very few entrepreneurship activity in this. When you go for this metal, whatever you have, like if you go for temple or somewhere, you will get some shapes like some sheet metal carved or engraved, like formed some images, some ideals, something like that, or some we used to call this some checker, whatever you have, like all this are done with this. Either you have something like this, whatever you have, like whatever the things you have, so everything will be done with this forming process. So these are the research as well as entrepreneurship ideas that you can generate from forming process. Next, moving on to, of course, my area, which is welding, and this has a huge scope. And when you go for welding, how this CNC can be actually interlinked with this processes, of course, the robotic welding. When you go for robotic welding, you have two sessions. Weld is like completely on like continuous welding, and one is going to be spot welding. And when it is going to be continuous welding, it is completely on robotic arc welding process. And what are the advantage of this article arc welding process? When you have something to be welded like this, of course there should be a worker who goes there and do all the welding process like this, and do the rimming, cleaning, everything. Intricate shape where you cannot put your hands inside, maybe it is going to be hard to like where you have to put your hand inside, and that is completely replaced with your robotic arc welding process. Again, that robotic arm, whatever is being there, that is completely controlled by your CNC controller, where you have the back end with your CNC controller. So you have to position the image, like it has to move in X coordinate this much, Y coordinate this much, and it has to step over here and start with the welding. Then it have to turn around back in Z axis, like it has to rotate in Z axis, and you have to go for underarm welding, like how this welding has to be done. So this CNC technology has a wide scope in this robotic arc welding, where completely the arc welding of this robotic is automated by your CNC controller. So even for doing something with this, you should know what is basic CNC, what is basic CNC programming to start with this welding process. Though you have XY system which is being done, and there are two system with this, Fanuc coding and Siemens coding. Again, both are quite different, where they have some different technology which is used. So for starting with this as well, you should know the basics of CNC simulation, like or coding, which is to be given completely over the process. Then of course spot welding. Spot welding, what is the necessity for knowing it is, you should know the complete coordinate of a car where each and every spot has to be made. Because when you go to companies like Maruti or Hyundai, where they are completely automated with the spot welding, you have minimum 10,000, maybe 10,000 to 50,000 spot welding in the complete car manufacturing, where you could see it over here, here, oh, there's a spot here, 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 here. So all this spot welding are completely done by the machine, but here you are not directly controlling it. You are not taking it and putting it there, taking it, putting it there, taking it, putting it there. This is completely automated. In that condition, you should know the complete coordinate of the car. What is the X point? What is the Y point? What is the Z point? What is the X point? What is the Y point? What is the Z point? Where this spot has to be printed. Maybe this is around 30X and 20Y. Maybe from this point it is around 20Z. So you should know what is the exact point where this spot welding has to be done. Again, for this also you should be knowing what is coding. So more than that, like when you start with your basic automated welding research, you should be knowing the CNC coding behind it to operate the machine as well. You cannot like directly feed 100 mm, 200 mm. It will not happen, because it can be applicable only for X line 100 mm, Y line 100 mm, Z line 100 mm. So only for those you can directly go for this. One second, I'm getting. But rest of the process you cannot go with this because you should know what is the coordinates of the complete system that is completely done with your CNC coding to understand this welding process. Of course, second thing what I take is my own research topic, friction stir welding. My guide, when he was taking class before a couple of days, he was saying like I'll be saying something about it, and it's my responsibility right now to explain you what is this process, how this CNC is actually worked in this process. Because friction stir welding machine mostly it is of 4 axis. Now we have 5 axis as well. This 5 axis machine, whatever you have, like Z, X, Y, Z, and this rotation we have, this rotation is fourth axis, and this side it can be rotated, like this is your fifth axis. That is how this 5 axis CNC machine is completely used for FSW process. Again, FSW machine is again used for welding, and mostly like this is where I was doing my project in ISRO for their complete setup of cryogenic fuel tanks. So there are different parameters where this rotation speed controlled by CNC, where what should be the rotation, the travel speed, how much it should travel in X, how much it will travel in Y, how much it should travel in Z. Suppose like if it is going to be two welding sector like this, how this has to be welded, how much it has to travel in X, Y, Z, and tool profile and tilt angle or the other things whatever it have. So everything except this, everything has the control of CNC over here. This intricate profile has to be completely first go with turning, then this has to be either go with milling process, or this has to go with this hobbing process, like where you just change small change. So to understand this as well, to get this as well, direct conversion of design to coding should be known. Only with that you can create this design. Even if you create a CAD design, you should know how to control the machine to run with it. So for that as well, you will be knowing this. And this is what all about my project is. I was working on this cryogenic fuel tank welding, where the other welding processes were not giving more than 40 to 50% of the efficiency. We were able to get around 80 to 90% because this has the intrinsic property where the material property remains stagnant from minus 250 to plus 260 as well. So these are the various application what this particular welding process is being used. Of course, like mostly on aerospace, because there the welding should be more similar to that of the parent material. It cannot have any heat effect. So this particular welding technology is mostly applied, and of course you have something on marine as well. And again, you have something on friction spot welding as well, where now the spot welding technology is completely replaced with friction still spot welding. Whatever the coordinate system, again you want to know the things as well. This is the complete thing which is completely made with friction spot welding, where around 7,300 fasteners are approximately replaced by just 263 friction welds. Like the fasteners, whatever it was completely used, this Eclipse 500 business board, it was completely used with this particular technology to work that. So again, this point you may not know how the machine should move and do the weld. This point you may not know how the machine should move and move. Again, you need this CNC basic programming to understand all these processes. Then comes to the final topic before moving to the simulation part, additive manufacturing. In additive manufacturing, the first and foremost thing being from welding side, I will take additive manufacturing as wire arc additive manufacturing, which is giving the wide scope right now, because if you want to create a metal component and add it to it, you don't want to fix it and weld it, fix it and weld it. You don't want to do what? You just hold the component, you do some additive wire arc additive manufacturing, and you generate a component. If you want, you can just go for some machining over it. So the first thing will be wire arc additive manufacturing process. So why this is actually being used is, if you want an intricate structure like this, either it has to be welded or it has to be machined. But the problem is, when you have a thicker material and that has to be welded with fins of smaller thing, you go for welding. But now the welding again is going to create a problem, because this is going to be thicker material which will take too much heat input, but this is thinner material that will melt off. In that case, you don't have an option to go for welding, because again it is going to be weak, it is going to be create weak portion in this one. Or if you go for machining, which will be a stupid idea, because you may need lot of time to machine it and get into a final product like this. So that is completely now replaced with wire arc additive manufacturing process, because this is going to have a same distribution of things, material over the process. And again, this is completely based on this computer numerical control, where each and every coordinate, it has to move from x 10 mm, then it has to move to z 1 mm, then again you have to move in x 10 mm, then again z. So it has to go layer by layer, layer by layer, layer by layer. So your coding should be in such a way that it is going to create a process in the basic from bottom to the top in complete way. So that is where your additive manufacturing technology completely uses this one. And of course, other additive or 3D printing technology, these intricate steps, whatever you have, is completely made with your process. And few of you may not be knowing, like even this from this small CNC 3D printing machine, whatever is here with some fusion deposition modeling base, which can build up some small components to a bigger component where you have an intricate shape, or the metal printed 3D manufacturing, or even organs like organ printing. Everything is based on your coordinate system, where you have to generate a CAD model. From that, like, you create a path profile, and that has a coding section at the back end. So if you want to play with the structure, you don't want to change the design after exploding it to the machine. What you have to actually do is the machine understand the coding language, so you can just retrieve the machine data. This actually simplifies your designing effort, because if you want to have small projection, okay, this is done. When you want to have small change over here, getting it design will be still complicated, because you have to completely change that. But instead of that, what you can do is, when you have the complete code generated for this profile alone, you know it is going to be some I mean, what is that, clockwise, counterclockwise, like counterclockwise rotation, and it has to move downward, and it has to go for anti-clockwise movement and move upward. So this coding can be easily replaced into the machine. So the machine now understand it is not the actual design which is getting extracted. The small changes which is to be done, which is quite complex with your design, because you have to completely change your design and export it and get it back. So once your design is converted into complete loading, when you understand the coding process, you can generate these small design into the actual setups and get your product output done. So that is how this additive manufacturing is actually more helpful with this CNC process. Once you understand the CNC coding, you have lot of use case like that can have wide scope with this. Of course, this is completely metal 3D printed, where the conjugate shape, what I told, like, everyone when they go for additive manufacturing, first thing what they try is this one, because this is the conjugate shape. If you are getting well versed with that, either of the product what you are going to design, that will be perfect. That is what they believe right now, because the basic training of your additive manufacturing will be in wire arc additive manufacturing will be with this. So of course, like, you have organ printing. So completely it works with coordinate system, where the complete heart is being scanned, the coordinates points are taken, the clouds points are taken, keeping as some reference. So that is completely converted into image. That image is completely converted into a cloud points. That cloud points data are completely converted into a CAD model. That CAD model completely generated into coding. You start with this printing process. So when you go for additive manufacturing, you have a lot of research scopes. If you understand the basic CNC, in biomedical as well, you have, like, when you start with, you have dental portion, you have the vascular graft, and in abdominal replacement, or in internal nails ligament portion. So all this are now completely replaced with your implants. So all these implants needs basic knowledge of design, and even after knowing the basic knowledge of design, customization is not going to be very easy with this. Only if you understand the codings, CNC codings, based on people you have to customize CCR everything, because the design will have some data, and when you want to remodify the design completely for a person, it is going to be completely a huge task where you have to completely remodify data structure. But if you understand the coding, that coding generated from this design can be easily replaced. And what are the possibility you have in this research, the basic things will be understanding of CNC coding. So without CNC coding or the cloud point, you cannot go for any of the additive manufacturing, that too in bioprinting applications. Of course, in aero space also you have lot of things with your this one. One second. Tabish, I'm in class. I'll call you back. So this has a wide scope in aerospace, and this is the GTR engine is the latest thing what is being done with this completely additive manufacturing technique. So as my area of research is completely on additive manufacturing, you have lot of scope in this where just with CNC, it took CNC knowledge in FDM based machining. The technology has completely brought down. This is by CNC machine where it took around 30,000, 30 lakh rupees. But by applying the knowledge of CNC in 3D printing process, where fusion repulsion milling is only 10 by that too within 6 weeks. So this is how the knowledge in CNC can be applicable in different manufacturing process to optimize it, to make it into a smarter one and get your product very ready in the market. And of course, like these are the things what I have collected from the local thing where this CNC technology is actually used for 3D printing of stuffs. And of course, biomedical, you have a lot of scope in your research area where you have all the prosthetics or this implants that is completely made with your 3D printing process. And for all this 3D printing process, more than design, you should know the basic knowledge of CNC as well to change the structure or customize that into a particular product. So this is what is happening. So you take the data, then that will be stored like from this, like you scan the data and that will be processed, and that will be completely converted into a model, and that model will be going for printing. So in that case, like this also has a vital scope. There are too many things, I don't have much time right now to explain about this. So there are too many. Architectural and engineering has again this intricate step. Whatever you do, you cannot just do the design. Suppose like if you say like there should be some change in this particular area of design, again understanding the CNC will easily put this loop from straight to cross. So that is the beauty of knowing CNC. And now this CNC technology has been completely applied in 3D printing for cement like construction also, only with your X, Y and Z axis. Just by the control of X, Y and Z axis, what are the things the material has to be flown, and complete thing. This research is now going on in IIT Guwahati, where this research is now made into a complete product in IIT Madras. There is a startup based on this cement based, concrete based 3D printing technology that gets you a complete support of this. So these are the different aspects what you can get out of this. Now coming to your simulation part. So first will be your part design, second will be your design convention, then preparation of CNC machine, then implementation, program preparation. So in this part you could see in the machine only the coding which is being running. So I'll just take next 10 minutes to give a basic knowledge about what you have in your CNC basic simulation. This software is paid actually. You can have always the trial version. You can go for this CNC Simulator Pro. This is the software name where what I use for this. And there are too many modules, like you can check with if you learn like what you have in your G code or X axis, Z axis movement, or M code, whatever it is to be done. So everything from your normal turning process to high level of drone technology, everything is available. So once you understand the basic machine process, you can use this particular software to simulate and check whether this is working or not. So I'll just simulate you with few process. This is the basic thing what I have got from the software to understand, I mean, teach you like what is the normal facing or turning process. So you have an embedded workpiece and you have the machine center which is being done, and this is the normal facing operation, facing cycle which is done with this. Like I think you could see this normal facing operation which is done. If you see this, like G0 is the end position, where G01 is the linear movement, where X is moving to a rate of around 95, and then it starts with Z axis around 213. So this normal cutting, whatever is happening, everything is based on coding. Here you could see the operation, here you could see the movement of coding. So these are the basic things that can be done with your turning cycle, like or turning center, whatever you have. And then like when you go for grooving as well, like intricate part, everything need the knowledge of coding. Like this can be simulated completely with this software and check like whether it is going right or wrong. Even if you make any error, the software will say these are the things what you are making into a stuff thing. And I'll just stop with this because I'll go to the next operation on stop this, and I'll load one more machine. Turning, you have too many turning centers. I'll go for milling, and this is the milling center what the Symantec we use. Like I've just had got some coding with that. So when I simulate this, yeah, so now you could see the basic operation that is happening with this. I'm just getting some intricate profile with the milling operation, and the coding, like you can understand very easily. You cannot, like, you need not to worry like this or these many codings for this. This is some completely like loop, like or same thing with some increment, maybe X, I mean Z 5 increment. You will have rest of the things. So that can be completely done with it, and even some intricate profile are also possible with this. So this is where you have basic simulation with your milling. What are the coding you have? You can just try the software. Only thing is, this is a trial version actually, so you may not have much thing. But this one, like, I got something for getting your final output done. And next thing will be stop simulation. Okay, I've stopped it.
Sir,
Yeah,
sir, one doubt, sir.
yeah.
Sir, when we are machining, I mean, when we are giving the code, no, it will show the time also, sir.
This one, here you have the thing, and this is what that's what I'm like. We always work for the time control, as Sajid sir was completely saying. That was as what like love simulation, because they have like camp packages, everything, which is around 15 to 20 lakhs for each and every software.
Okay, sir.
So that's what that's what I have given in my topic. It is completely on basic.
Okay.
So,
Suppose if it gives the time also, is it correctly, I mean, matches the time for the machining also, sir? The
no
actual
ma'am, no ma'am, no ma'am, no ma'am. I'll say what is the practical difficulty in it. If there will be around 5% error, because there is no friction in the simulated software. It will move just like that and move on. But if your machine is not in a perfect condition, maybe like the lubrication is not proper, maybe some module or fixing is not proper, in that condition what will happen is it may get stuck. There will be a loss in 1 second, and it will move on and start with the process. So it is not accurately saying that it is predicted to have maybe around 2 hours, but actual printing it will take time. The same thing, what is the problem I'm facing with my 3D printer as well, because it will estimate to be around 1 hour for getting one product done, but it will take at least sometime it will be 1 hour 20 minutes or 1 hour 10 minutes. So whatever is simulated over here, it is on free space without any obstacles. But when you go for actual application, you have a lot of obstacle in it, which actually drags your time. So it is not like what you have will have always that. It is not the possibility. It is not happening. Then coming with your turning milling, then I'll just show something on cutting.
Thank you, sir.
Yeah, yes, ma'am. And I'll just show something on this. Laser you would have seen, plasma, deep hole you would have seen, this water that I was saying, right? I'll just show something on this. So this software is very useful for your basic understanding how the CNC actually controls everything, because you can play with the code and you can see what is happening over here. Here water on and off, because there is a lot of slurry which is being applied over there, that should not create any mark over here. That should not create any mark over here. So you could see like how this complete water jet is being used. Here there was an order off, so there was no thing happening. So now the water is getting sparked, again the water is getting off, and it moves on. So say this is how this is again used in thing. So if you understand the basics of coding, like there are too many operation where you have a lot of scope in your research, this software will help you in understanding before going to the process what is going to be the actual output from the process. And only one thing what I can suggest, it should not be suggested, but if you have a lot of mail ID, like you can get trial version over a time, like that's how we work on this. But getting this software, of course, like when your organization is having some funding, it is always easy to get with that. Then I'll show you something on cutting is done robotics. This SimBot robo, yeah. Again, I have like the basic module where this is completely used in the welding or maybe material handling or pick and place robo, or the industry where the capture and movement is done. If you work on logistics or welding on automation of this complete thing can be completely used. And again, I'm saying this is something to understand the basic. It is just for beginning. So once you are well versed with that, the CAM packages can give you the actual model of holding a welding torch, creating a welding torch, or removing it, material removal, the tool path generation, whatever the advanced thing Sajan sir was doing, that was completely on it. And if you want to understand that completely, you should know the basic understanding of it, because this gives you the complete coding where each and every step, like if you don't understand, you can stop here and see, okay, what is the process happening here? And you can again play it. Okay, next this process is here. Okay, next process is this. Okay, pass again. You'll see, okay, this portion is going down. So you will understand each and every step in this particular software on using this. And one more module what you have in this is the 3D printing step. This is what actually happening with this machine as well. When you project something, there are a lot of coding which is being generated, and that coding is completely running this machine. And whatever coding which is being used, that has the so the layer by layer, it is printing the material and stuffs. You could see this layer by layer material is getting added on. Again, it is creating a layer of material. So now you stop here, you'll understand like, okay, this portion that is having a field of 4823, there is something which is happening with this tool profile. So you will understand each and everything what this coding is actually giving you. This software, if you are, this is well versed, so that if you use for some time, you will be understanding how this complete things controls the entire coordinate system in any of the machine process. Of course, if you think only this is what done with this, of course not. More than this, there are something where this drone based milling, when you have some underwater, now underwater drones are also existing. So when you go for repairing of underwater thing, like when you go for underwater, like for some welding or machining or something, you don't want to go with the machine. Like you can just hold here, control with your drones, and you can check what is happening with this. This is the emerging technology right now, and underwater drones are even actually available right now. So how to control that with your, how to include that in your machining operation? Of course, this is not going to be as easy as it is getting simulated, because there will be a lot of thrust force or a lot of payload which is being acting on it. So all this have different intricate shape, but still with a simple drone you can completely automate your technology and see what is happening. This has a wide scope right now in the market. And if you feel someone, those who are interested in gaming, I just want to show this to you. If you feel only this, what can be done with this? Of course not. Even a game playing can be, that movement of car vehicle can be done with this CNC coding. Like when you start with this, I'm just saying like G0 G01, it is going to be maybe y-axis, y it has to move 40, then x is it has to move 20. No, it will be again, maybe I'll keep 30, then again it has to take a turn on y again 30. You try to simulate this. Now the car moved here, turned here, and stayed at 30. So everything is possible with this. When you go for this one, the basic understanding you will get with this. I just showed you just to give you an understanding like what is this is. So this possibility is more with this particular mission. And when you start with this basic coding, just you want to know around 30-40 G code and M code, like what is linear interpolation, what is a probing cycle or phasing cycle, how it has to move from exact to y. So that is what all we want to know is. And finally, concluding with this section, the major focus of our research is what I am working on right now is we work on some COVID projects for creating some automatic bending come disposal machine. We have submitted one project on this and it is on process. And I do work on some underwater welding techniques where I got like some certification of scuba diving as well. Like then it was carried out in IIT Guwahati, completely on underwater arc welding, which is not existing in India right now. Where there are some 1 or 2 training centers where this has a huge scope of research. If you want to start with that, you can always collaborate. And we have something on new developed technology. We have filed patent on this as well. And of course, FSW we are using much. And this is what I've done in 3D printing. It was long back. Most of my students might be knowing it. Thank you so much for your patient listening. If you have any doubts, you can just ask, or if you have any queries, you can always reach me with this. Any queries from anyone? Yeah, audible.
Sir, what is the difference between arc welding and seam welding? Can you please elaborate on that?
Seam welding uses a roller, just like a spot welding. Seam welding is another technology where you have the bottom portion and top portion, which has an electrical contact. With that, heat is generated that moves on a roll. Arc welding is what you have MIG, TIG, plasma, everything that produces an arc. That is arc welding. Everything is arc welding. Arc welding is mostly used. Now we have tandem, hyperfill, all this are there. Seam welding is like you just want to join two material where there will be a roller of color thing, where there will be heat flow, mean electricity flow at top and bottom, that will be rolled off, and due to the heat and the pressure which is being applied, the welding will happen. Arc welding is from normal manual to the advanced robotics welding. Everything is arc welding. Any doubts? Any other doubts?
Sir,
Yeah.
Sir, can you share this PPT because it will be very helpful for me, sir.
Yeah,
That's why I am seeing the whole lecture, and I think that this is very helpful for us.
yeah, yeah. I can share. No issues. Anyway, I can share.
Okay,
Yeah,
okay, sir. Thank you, sir.
yeah. Any other thing? Yeah, yeah. I'm audible. Yeah. Hello. Yes. Hello. Yeah, because any more queries? Any more queries from anyone?
Okay, I will write down my query, sir.
Yeah, yeah, yeah. You can write. I can read it. I'll just talk to that. I can just read it from your chat box.
Sir, if we are doing robot mechanism,
Hmm.
robot arc welding,
Ah,
sir, there will be lots of errors there.
who told?
There will be not accurate there.
Who told?
The, sir, there will be no there will be robotism.
No, you are
Yes, I
predicting
will.
there will be a lot of error because I work with robotics building and erring is human, not machine. Machine won't do mistake. It will do what you are given. If there is a mistake, then you have coded it in a wrong way. Because I worked on robotics welding, I worked on TIG welding for around 2-3 years, and right now we started with some tandem MIG, which is the advanced version. And of course, like it won't chaos because that will give you, even when you are manually doing it, you have this phase of movement will not be easy, but when you go with robot you will get a perfect welding than a normal welding, and heat affected zone will be maintained in a proper way. And I don't even accept this robotic welding will be defective. It is not the case. Now it is, everything is optimized and it is widely used everywhere. Now everything is automated. Robotic welding is not that error as you think of, then
Okay.
human made. Yeah.
Thank you, sir.
Any other queries? Any other queries? If not further, yeah, sir, thank you for your nice presentation. What is the factor affecting for FSW biometallic joint error found during the welding process? As I hear you have done project in ISRO, so what is the particular application for space industries for the biometallic joints? Uh, are you a research scholar who is working on this? Because recently we have submitted two proposal on this biometallic joints. Maybe like this is what is called as friction based additive manufacturing. And when you go for, like, I'll just say directly, like if you want to work on, you can work. Mostly we are working with copper aluminum joint and aluminum steel joints, where the implicate shape of everything is like, of course, I can say the direct example. 2024 is an aluminum series that has the structural property which cannot be welded or jointed with anything, only it can be fastened. But that can be welded with FSW process. 2024 has wide application in ISRO. You can check with that. Even I can give some scientist contact over there as well. So joining of that with the other particle is completely done with this one. That is how this bimetallic joint is actually happening. I tried with copper and aluminum. I failed. Then I tried in IIT. We succeeded. And now FSW, like even if you are giving wood, we can build it. We are quite good in that. Bimetallic joints, it is possible. Even I have even a paper on aluminium magnesium of bimetallic joints. It was published in 2018 somewhere. You can find, if you type my name, you will get it. Whole scholar, you will find it on there. Any other doubts? Any other queries from anyone? All right, thank you much. Yeah. Any other queries? Yeah, forward to you, Kurat. Thank you.
Thank you, sir. Thank you for an interesting and informative lecture.
Thank you, sir.